Should I go for Oracle 12c certification or wait for Oracle 18c certification to be released? Welcome back guys, I'm your host Arun from DBA Genesis, and let us start today's show with the first question of the day. What is the difference between row chaining and row migration? Now this is a very simple question, and I 100% know that every DBA interview, the interviewer would definitely ask you this question, the difference between row chaining and row migration, right? So what is this row chaining? It's very simple. You have a row which is bigger than the size of the data block. So what will happen is, let's take you have 4 KB block and your row size is 8 KB. Then what will happen? Row chaining will happen because the row cannot fit into any one block. So what Oracle will do is it will split the row and then it will store one part of the row in one block and the another part of the row in the another block, and also the previous block will have reference to this second block. So the simplest way to avoid row chaining is to make sure while you're designing the database or while your database is in design phase, you are analyzing the average row length. I know it's a tedious job, but if you can get the idea about the average row length in the biggest table of the database or the highly used table, and then you decide the block size, that definitely helps you reduce the row chaining. Now what is row migration? Understand this, you have a record which is staying in one 4 KB block, alright? So this record size is 3 KB, it is residing in one block of 4 KB. Now as a DBA or as a user, you updated this record and now the record size has grown to 8 KB. So what will happen? This record cannot fit into this box, right? So Oracle will move this record into some other block. So what happens in this case is, row is being migrated from one data block to the another data block. In this case, the old block will also keep the reference to the new block ID where the record resides. Now, does that mean the index will get updated with the new data block? No, the index will have reference to the old block and the old block will have reference to the new block where the row has been migrated. Now, does that mean that it will have an impact on the database performance? Of course, because see, earlier when you used to run a query inside the database, the query used to look at the index used to get output from the first block, right, where the row was residing. Now when you query inside the database, the query goes to the index looks out to the old block has the reference to the new block, and from the new block the output is given to the user. This way the row chaining and row migrations both impact the database performance, because whenever there is row chaining or row migrations inside the database, what happens is there is an increase in the number of IOs inside the database. Now your Oracle database has to perform few more IO steps in order to get the right data to the user. So to keep it very simple, row chaining is when your row size is bigger than your database block size and the row cannot fit into that one block. So the row will be splitted and it will be fit into 2 blocks. That is row chaining. So the first block will have reference to the next block where the other part of the record is residing. And row migration is when you update a record, and after updating the record cannot fit into that particular block, and then the record has to be migrated to some other block. And in this case, the old location where you had the record, that will have reference to the new location where the record resides right now. So with the row migration, what happens is the index will still have the reference to the old block will reference to the new block. I hope that will clear your confusion about row chaining and row migrations. Let's move on to the next question. How many minimum disks are required in external, normal and high redundancy? So guys, for this question, I would like to demonstrate something to you guys so that you understand what is redundancy, and then I'll explain this answer. All right, I'll be back in a minute. Alright guys, I'm back. So I have these three phones and I'll try to use this as an example to explain you what is redundancy. Alright, now understand this guys. We have a system, and any given system, let's take it's your laptop, server or your desktop. What happens is you will have just one hard disk. Understand that I have three hard disks over here. All these three are hard disks. So this is one hard disk. Now your system or server will have one hard disk, right? So what happens if you have just one hard disk? Like your data is being stored in this hard disk, and if there is any crash failure of this hard disk, your data is gone. So probably you might use some recovery tools to get the data, but understand in a real-time environment, when users are connected to the server and they want the output for their queries, you cannot just wait to remove this hard disk if it is corrupted, send it to a data center, ask the users to, hey, wait for some time, we have sent the disk for repair, and once the disk comes back, and then you put it into the server, and then the user will get output of the query. It does not work like that, right? So in this case, what happens is there is something called as redundancy in real time. So what is redundancy? So you have one hard disk. Let's take, I increase the redundancy of my server or the storage to, let's take 1. So when I say redundancy, the literal meaning of redundancy is copy. So what I'm going to do is I'm going to maintain one exact copy of this hard disk on the server like this. So now whenever data is being stored on this primary hard disk, by default the storage server will create two copies, and those two copies will be stored in these two hard disks. So what is the benefit? Let's take the primary hard disk crashes. I can still remove this hard disk, send it to the vendor and ask the vendor to recover this disk or probably replace the disk. Meanwhile, the users are getting output from this redundant disk, right? Now let's take the service provider or the hard disk vendor told us that the corrupted disk is completely gone and you need to use a new hard disk. So let's take they replace the disk. All data on this disk is completely gone, but still users are getting output from this one disk, right? So what we can do is we can get this hard disk, plug it into the server. So what will happen now? The benefit is the storage software is so smart, it knows that new disk is being inserted into the server and these two are redundant disks. So that means this is the blank disk, the first one. This one has the data. Currently application is accessing this data. So automatically the data from this disk will be copied to this freshly inserted disk, so that this disk copy is being maintained in this disk. Because as per redundancy rule, both the disks should have exact same data, right? Now, while this happens, if you insert a new disk and you have data in the old disk and both are redundant disk, automatic copying of the data will start from the disk that has data to the fresh disk. Now, this copying of data is known as rebalancing. Because both the disks were not balanced, one was empty, one had the data. As per the redundancy rules, we need to balance both the disks, and due to this, both disks will act as a redundant copy. Now again, when users are querying the database, they will get the output from any one primary disk. It can be this one or this one. And when users are inserting the data will be inserted again in both the disks. That way we will maintain two copies. So this is the example about increasing the redundancy to level 1. What if I increase the redundancy to level 2? Now redundancy means copy, right? So when I say redundancy 2, it means I want to maintain two copies of the same data. Okay, so one will act as primary disk and I have two other disks which will act as redundant copies, right? So now when we have three disks, that means Whenever a user is storing the data into these disks, the data will be stored in the primary disk, and we will also maintain two copies into disk 1, disk 2. This way, let's take the primary disk crashes, okay? We send this to the vendor for the repair, all right? So now users are getting output from the second or the first redundant disk, okay? So it is first redundant disk, this is second redundant disk. What is the meaning of redundant? Copy. First copy disk, second copy disk. Primary disk is crashed. So users will get output from the first copy disk or first redundant disk. Assume that even this disk crashes. We send it to the vendor, and now still the users are having output from this second redundant disk or the second copy disk. Now you get these two hard disks back from the vendor saying like, okay, we can't repair these disks, so we are giving you fresh disks and you can use it back into your environment. So what you do is you insert this disk and you insert this disk. As per rebalancing, all the three disks must be exactly same. They must have same data. But what is our condition right now? The last disk is having the data, but these two are blank. So rebalancing will happen because all three should be exact copy of each other, right? So what is rebalancing? Rebalancing once again means whichever redundant copy is blank, the disk which is having the data will be copied to those redundant disks so that you rebalance and maintain exact same copies of all the disks. So that's an amazing example, I believe, guys. I think if somebody could explain me this way, I would have enjoyed it. All right, let's get back to the question. All right, guys, I'm back. So let's look at the question once again. How many minimum disks are required in external, normal, and high redundancy? So external redundancy means you do not want to maintain a copy of the disk inside the ASM. You are telling ASM that I will maintain the copy of the disk into an external disk, which you may or may not maintain. It's up to you. So for external redundancy, if you are setting up into a disk group, you at least need one disk because that will be the disk to store the data and that will be the primary disk, right? Now, if you go on increasing the redundancy to normal redundancy inside ASM, so for normal redundancy, you need one minimum copy of your primary disk. So which means you have a primary disk and you also need one more disk to maintain a copy, right? So that is normal redundancy. That means you need minimum one disk to be maintained as a copy of your primary disk, right? And if you increase the redundancy to high redundancy, it means you want to maintain at least two copies of your primary disk. So this is my primary disk and I have two more disks which will act as copy of the primary disk. So if this disk fails, then I still have two more disks to get the data output, right? I hope this will help you. So let's move on to the next question. But before that, guys, I have a quick question to all of you and I want you to comment below this video. Okay, so assume this, each disk is of size 1 TB. All right, so this is 1 TB, 1 TB, 1 TB. I have 3 TB disks. So if I configure all these 3 disks as part of one disk group, okay, so I have one disk group, these 3 disks are assigned to that one disk group and the disk group redundancy is external. So what will be the exact size of the disk group? Okay, that's the question 1. The next question I have is, if we have one disk group and if I assign these 3 disks to the disk group and the disk group redundancy is set to high, then tell me what will be the exact size of the disk group. Once again, each disk is of size 1 TB. I think I should get some amazing answers to this question. All right, moving on. The next question we have is, could you talk about recursive calls in Oracle? Of course. So for recursive calls, let us understand this example. See, you make a call to Pizza Hut, okay, and then you tell Pizza Hut that you want to buy a pizza. So what you are doing is you are placing your request to the Pizza Hut billing counter, right? They take your request and then they will process internally the pizza and you will get the pizza. For you to get the pizza, the actions that you do are you call the Pizza Hut, you place the order, you get the pizza, right? That's it. But internally inside the Pizza Hut, what goes in? Once an order comes in, the billing counter will call the kitchen and say that, hey, you need to make this pizza and these are the specifications. And let's take the kitchen guy is falling short of ingredients. The kitchen guy will call groceries department and ask them to send some groceries. The groceries department, if they are not having the specific groceries, they would definitely make some more calls. Ultimately, you as a user, you placed a pizza request, you got the pizza, but to deliver your pizza, there are some internal calls that go inside the Pizza Hut, right? From one department to the other department. Now, these calls are known as recursive calls. The important point over here is the recursive calls are required in order to complete the main request, right? So if the billing guy does not call the kitchen and the kitchen guy does not call the groceries guys, the pizza will not be made. Now if the pizza is not made, the Pizza Hut cannot deliver the pizza. So this is a very basic example of recursive calls. Now let us relate it with the Oracle database. Now inside Oracle database, whenever you try to place a request, whenever you write a query, what happens is inside the database there are certain other calls that happens. So Oracle will try to query some internal base tables, Oracle will try to reach out to some indexes. Now all this inside Oracle processing is known as recursive calls, and it is 100% mandatory to perform those recursive calls in order to process the main request that is submitted by the user. Now that being said, there are ways to reduce the recursive calls, but when you know what is causing the recursive calls. So even before you want to reduce the recursive calls, first we must understand what are the types of recursive calls that happens inside the database. So the first type of recursive call that I can recollect is the hard parsing. Let's take you run a query, the query plan details and SQL ID is not available in the shared pool, then it will go for hard parsing, and that again goes for a recursive call. It has to fetch the record from the database, put it into database buffer cache, and then give the output to the user. Do you see? Lot of steps, right? Now that is one type of recursive call. The next one is recursive call due to the PLSQL. So let's take you write a PLSQL block, and to execute that PLSQL block, it is contacting some other procedure, that other procedure is calling some other procedure, that becomes a recursive call. So how do you reduce the recursive calls in a PLSQL block? Is by tuning the code and looking at where exactly Oracle is making a lot of recursive calls. The next type of recursive call that we have in Oracle, when you use functions or triggers inside the database. So when you use a function, the function will try to get the code which is related to that function to solve that problem, and definitely Oracle will make some small internal calls in order to get the query executed, and the final output will be given to the user. The same thing happens when you use triggers. One trigger might contact another procedure inside the database, or it might execute another SQL statement inside the database. So all these steps that go inside a trigger will also contribute to multiple recursive calls, right? Now I think the last one that I can recollect is the recursive call caused due to the space request. So let's take you're trying to insert a record inside the database and there is no space available in the exact segment where the record has to be stored. So what will happen? Oracle needs to find another segment where it can store your data. It needs to allocate another extent, another data block, so that record can be stored. So when you do this, it's again getting into recursive calls. All right, now that being said, I think I mentioned 4 types of recursive calls inside the Oracle database. One is recursive calls caused by the hard parsing, recursive calls caused by the PLSQL, recursive calls caused by the space issues, or recursive calls caused by the functions or the triggers that you use inside the database. Now let me give you an example on this. So we actually had a client, and when we were trying to look at their execution plan, they had a query and I was monitoring that query. And when I looked at the query execution plan, I saw there were like a lot of recursive calls. So one of the recursive call reasons is because the query is going for hard parsing, and a hard parse simply means that we cannot parse the statement because the statement is not available in the shared pool. So because of this, what we did is we helped the client to increase the shared pool size, and that way we could see that that particular query and also some other queries which were going into a lot of hard parsing, we were able to solve that issue. And by the way, I think if I remember, it was a very silly query and it was going for around 240 or 250 recursive calls just to execute one small query. So if you try to enable user trace inside Oracle and then you see the trace file and analyze the trace file using the tkprof utility, what happens is you will get to know where exactly Oracle is spending a lot of time to execute the query. Now in these kind of conditions, when you see a lot of recursive calls, one of the way to solve that problem is by increasing the shared pool size. So all in all guys, recursive calls is not bad, but too much is bad. You need to know the exact reason. Most of the times when I see a lot of experienced DBAs, they say, oh, my environment is having a lot of recursive calls. Understand, you cannot avoid recursive calls. It is important to have recursive calls in order to execute the user query. And it's not bad, and that's how Oracle works. You cannot have recursive calls as zero. It is impossible. But like as I mentioned in one of our clients' environment, when we were trying to debug the query, we saw the query is going through 240 plus recursive calls. Now that is bad. We don't think that a query needs 250 or 240 recursive calls in order to execute the data. Now that being said guys, I hope that helps. So that's all about recursive calls in Oracle. So let's move on with the next question. While I was trying to switch over, I ran into issue. What's your recommendation? Once again, open-ended question, and I really can't help you like what was the issue. I cannot assume and give you all the answers, but it would have been good if you could have included the code or the error from the alert log, or if you could have mentioned the exact error or the issue that you faced. So I'll go with my assumptions. As far as my experience is concerned, 97% of the switchovers will fail due to the misconfiguration of log archive dest to parameter. Because I know many of the DBAs who try to configure a physical standby, they just fire up Google, they search for a blog post, they copy the log archive dest to parameter as it was used by the blog writer, and they will just copy it in their environment. They do not wait and analyze why those specific parameters are used by the particular user or the writer or the blog from where they are copying. If you just wait, if you hold on to log archive dest to parameter, review each and every single parameter that goes into that entire parameter, and try to understand what is the impact of each parameter in your environment, that's when it makes the change. So 97% of the time whenever there is a switchover issue, I 100% go and attack onto the log archive dest to parameter, because most of the times if this parameter is not set correctly, there will be a problem in the switchover. That being said, I think one more problem which I have observed when switchover fails is the standby redo log files. I'll tell you this, if you want to configure a data guard environment, you can configure it even without creating standby redo log files on the primary. So you have a primary database, you have a standby database. Lot of immature DBAs, what do they think is SRL, standby redo log files, are to be created only for the standby database. It does not work like that. You can create a physical standby configuration where you have primary, standby, and only the standby has the SRLs, okay? But on primary, you are not creating any standby redo log files. So when you try to switch over, your primary has become standby, but standby is not having SRLs, right? So how will the configuration work? All in all, these are two of the most important issues which I generally see whenever there is a switchover problem. Now, apart from this, definitely there might be other issues. Sometimes there is issue with the MRP, sometimes there is issues with the way you perform the switchover. Sometimes it is also issue with the data guard broker in case if you are using broker for switchover. Sometimes there is issue with the listener, or sometimes there is just the issue, right? So it depends. So for this open-ended question, I think those would be my recommendations. Go ahead and check what was the log archive destination 2 parameter in your environment. All right, let's move on. What happens in Golden Gate configuration when you perform source database point-in-time recovery? How can you fix it? Amazing question, because you know what, guys, you won't find answers to these kind of questions anywhere on the internet. Like, you can't even find answers to these kind of questions with Oracle also, or neither Oracle will release any white paper or any kind of documentation to solve these kind of problems. These are actual real-time problems that happens in an environment, and that is where if you can deal with this kind of problems, you become an expert DBA. All right, leaving all that, let's come back to the question. So let us understand the question. I think I'm falling in love with the question. So I'll explain the question to other people who were unable to understand this, and then I'll try to answer this one. You have a source database, you have a target database, you have Golden Gate configuration, right? So Golden Gate is trying to replicate one table, one schema from source to target, all right? I'm trying to keep it as simple as possible. I'm just using one table as an example for this question, otherwise it will increase. I mean, the length of the answer will increase. So I have the source table or source database, target database, Golden Gate configured. I have one table which is being replicated, right? So on this source table, let's take, we have 10 records, and all the 10 records have been replicated onto the target database. Now, as per this question, let's take the source database. We want to perform a point-in-time recovery, and once you perform a point-in-time recovery, in the same table, only 5 records will be available, right? Because you are going back in time. So as you go back in time, at that particular point of time, only 5 records were inserted into the source table, right? Now look at the configuration. In the source, you performed a point-in-time recovery. There were earlier 10 records in the table. Now there are only 5 records in the table. So the table has been reduced. At that particular point of time, there were only 5 records, correct? On the target, other hand, you have all the 10 records, because earlier Golden Gate was replicating, correct? At this stage, Golden Gate does not know what to do. So what Golden Gate will do is all the processes will become abandoned because they cannot understand what to do. So that's the exact question that we have. So now the other part of the question is how to fix it. Now in this kind of scenario, guys, what we do is, let's take, you perform a point-in-time recovery over here. So first of all, if Golden Gate heartbeat table is enabled, that way I think you should have it enabled in a general configuration. And in case if you did not enable the heartbeat table, that's okay, because I've seen most of the environment, they do not enable the heartbeat table. So at this stage, the biggest question is you need to know the exact SCN when you're opening the source database, right? So definitely if you're performing a point-in-time recovery, you would definitely have the SCN number. So once you have the SCN number where your source database has been recovered in the past, you take that SCN number, and on the target system, the table space where the target table resides, where we have the 10 records, you perform this table space point-in-time recovery. Not the database, only this table space where the replicated table resides. So when you perform the table space point-in-time recovery to the exact SCN of the source database, what will happen? Now this table space will move back in time as it was at the time of source database table. So that means source will have 5 records, this will have 5 records. So the source and target tables have come in sync. Now once the source and target tables are in sync, you bring down your Golden Gate processes, restart them, and it will start working. I think amazing question. I guess guys, from all the episodes, this is the first question in relation to the Golden Gate. So let's move on to the next question. What is DB file name convert? It's a very simple parameter. When you try to clone from a source database to target database, what happens is the source database file locations is different than the target database file locations. So let's take on source, the files reside under /u01 mount point location, and on the target, the files reside under /oracle location. So when you try to clone using rman, you need to convert the data file names. So earlier the data file name will start from /u01. You want to change it to /oracle on the target. So you want to convert the file names, right? So this DB file name convert parameter will define what is the source path, and it will define the new path, right? So when you write it, the entire old path in the source database will be replaced by the new path in the target database, and that way cloning will happen. So automatically rman gets to know that, okay, if this data file resides under u01, I need to put it into /oracle, and that's what is this parameter called as DB file name convert. All right, I think that will help you. That's all I had guys for today, and I think you all enjoyed this show. I love some of the questions from this session, and I would request all of you to keep commenting below this video or try to send your queries to support@dbagenesis.com. Apart from this guys, I would request heavily use the support.dbagenesis.com website. I have some of the greatest articles put out there, and I'm still working on to put more of my own personal data or the personal scripts that I use in the real-time environment on the support website for all of you to just query and use it. That being said guys, let's move on to the most exciting part of the show, and that is the bonus question. Hi guys, I'm back, and I have chosen this question as the bonus question for this episode because I believe this is important for some of you who are struggling with Oracle certification. Let me first read out the question and then I'll answer it. Should I go for Oracle 12c certification or wait for Oracle 18c certification to be released? Now, my question to you would be, why are you waiting for Oracle to release 18c, 19c, or maybe 21c certification? We don't know, right, when they'll release. Understand this. For any kind of Oracle certification, let's take you today, complete the Oracle 12c certification. You can very well complete it, and once you complete it, let's take tomorrow Oracle releases the 18c certification, you always have an upgrade certification. Okay, so you become OCP, today you try to become 12c OCP, and forget about 18c, 19c, all those versions, or even 23c when Oracle will release. You only focus on your certification, and later on, let's take your employer demands that you should have 19c OCP certification. Then what you do is you simply perform the upgrade. There will always be an upgrade certification with Oracle, like people who are 11G certified, right? 11G certified OCA, OCP, they now have one single exam that they need to write so that their OCP will be upgraded to 12C OCP. It's simple. You don't need to follow the entire path of the OCA, OCP for that particular version. Like, let me clear this confusion for all. So I know the fear that you are going through. You mean you have 12C certification right now, so you have to complete OCA, then 12C OCP, and then later on tomorrow if Oracle releases 18C, you will have to again do OCA, OCP? No, not required. Why? Because with every version, Oracle again, as I'm saying, they releases the upgrade version. So what happens is, if you are already Oracle 11G certified, Oracle will also release an upgrade to 18C version certification. So by writing that one exam, if you are Oracle 11G OCP, 12C OCP, 9i OCP, 10G OCP, you will be automatically upgraded to 18C OCP. Now that's the benefit of upgrade certifications. So to answer your question, I would suggest you don't wait for Oracle to release 18C, 19C certifications. You just go with 12C and that's more than enough. Get the 12C certification done, and later on when Oracle releases the upgrade certification, you can always upgrade your certification. So later whenever Oracle releases the 18C, 19C upgrade certification, you can always upgrade your old certifications. Alright guys, that's all for today, and I will see you all in the next episode. Bye.